Bismillahirrahmanirrahim. Welcome back to our next session on developing the library for LCD character LCD display using STM32 microcontrollers. So in our previous demonstration, we had shown you the working uh, library which was developed for STM32 microcontrollers. In this series, I think it will take 2 or 3 demonstrations. We will go step by step to create the library from scratch. And we will be using our previous knowledge that we had discussed in the previous videos about how to interface with this character LCD. So let's begin. Now this is the practical time. So we will be talking more about the new development and how to make a library which will be a reusable code for our uh, new device. Let me resize my so that we can see all the stuff correctly. Right. So this is an existing program. I will be starting with a new one. So before that, I want to show you that we will be testing our library on Proteus, and also later on we'll be testing it on uh, maybe on the real LCD. I'll be using this uh, hardware design, right? So here I have this STM32 microcontroller F103C8, and here I have the character LCD. Just for demonstration, I have both the 16 by 2 and 20 by 4 character LCD. So if you look at the connections which I'm using on this particular thing, this is the ground pin of the LCD, which has been connected to ground. The VDD has been connected to 5 volts power supply, and we definitely in your real world this will be connected to a potentiometer and for contrast. The register select bit has been selected to PA8 pin of port A, and read write has been connected to ground to make it just for writing purpose, and enable pin has been connected to PA9. The data 0 to data 7 pins are connected to PA0 to PA7. So all the pins are on the same port. We will be assuming this library, just to make it a simple one, that all the connections will be on the same port, but they can be in different order. It is not necessary that this can be PA0 and PA1 and PA2 and this sequence. This can be here, this can be here, this can be here. Any combination, whichever is available on your real hardware, that will be uh, used. I think it's not really visible. Um, I hope it's visible now. Or let me adjust some. Right. So now you can see this register select bit is PA8, enable is PA9, and data pins D0 to D7 are connected to PA0 to PA7, all on the GPIO A port. And I'll be using this 20 by 4 character LCD, but the code will be the same for 16 by 2 and 16 by 4 character LCDs. Uh, in this example, I will be making an 8-bit library, which will be slightly easier to make and understand, and after that we will import it to the 4-bit library in our next discussion. So let's begin with the new code, new STM32 project. And we select the part number STM32F103C86. This is the one which is present on the blue pill boards. This is the microcontroller, ARM Cortex M3 MCU, 64 kilobytes of flash memory, 72 megahertz CPU speed, etc. So we continue and we give the project a name of LCD library underscore 2. I make it 2 because previously I have this LCD library project. And finish it. I will be importing most of the code from the previously written library, but we will be discussing them in detail here because I don't want to waste so much time. And right, so here is the configuration of the microcontroller. So we want PA0 to be an output device, GPIO output. PA1 is also GPIO output. PA2 is also GPIO output. All are GPIO output. PA3 GPIO output. PA4 GPIO output. PA5 GPIO output. PA6 GPIO output. PA7 GPIO output. And next, this is PB0, and we want PB8, PA8. This is PA8. This is GPIO output, and PA9. This is also GPIO output. So all the pins have been configured as output for writing data, because in this project we are not going to read anything else. And if you are making it for the real world project, you should go to this uh, system, and here debug, you will select the serial wire debug. But since I'm going to use it on the uh, simulator, I don't need this thing. Right, and after that, you save it and start generating the code. Right, so here is our project, and this is the structure where include files are in the INC folder, and the source files, which are the C files, are in the source folder. And this is your main program. I just want to clear everything. Let's turn everything off. This is your main program which has been just generated, and it has all the settings which we have mentioned in the uh, CubeMX settings. This is the clock settings and the GPIO pins, output settings, etc. etc. Now, before that, previously we have been writing code mainly in this file, and we have been uh, testing our code, etc. etc. The problem with this file is that whenever you change uh, the cube LED cube MX the settings, this is regenerated, and if you write the code uh, in a inappropriate place, that will be overwritten. So you have to write the code in between these areas which are mentioned here. So it is better when you are going to write a library, that should be a dedicated file and containing its all the structure and functions. So what we can do is we can create the file in the source folder. This is the easiest and simplest way. File, new, and here is the source file. So you call it, let's say, uh, lcd8.c. Always remember to add the c. So this file is created. This is a raw file, empty file with no code. And with this file, you will need an include file that will have the all the header definitions. So header file should be in the include folder, and in this folder you create a file with the same name, uh, new header file, and name it as lcd8.h, right? Same name, and finish it. So this is the header file and of LCD8H, and this is the source file. So header file will be in the includes folder. Here is the include folder, and the source file will be in the source folder. Now you can write the code in uh, these files. And whenever you will want to save these files, just copy these two files in one folder, and you can carry on them anywhere. And then whenever you want to use these files, you will have to import these files back into these folders. This is one way, right? And another way is, let's delete it, and let's delete it. Right, now we are back to the original settings. So add a new, and instead of adding the files, add a new source folder. So this is a source folder, and you name it as lcd8. So this is a new folder which is created outside the source and outside the include. It is not even in the core. It is a separate folder. So you can create files inside this folder, new source file lcd8.c, and also create new header file lcd8.h. Now this time both files lcdc and lcdh are created in the same folder lcd8. So this is more organized way of uh, creating your library, because the files are in a separate folder and they are not related to this core. You can carry on this folder anywhere else and just use it as a separate device driver or something like that. However, before using this folder in our main program, you need to tell the project that this source folder contains the files. So you go to the library, your project, and the project properties, and here in uh, settings you have to set the include paths, and include paths, rather you have to set the complete paths. Yes, include paths, and have you add the folder. It is in the same workplace, and this lcd8 folder. Okay, so the source folder has been added as a path. Click apply and close. Now, whatever the function you write, let's say we write a small function named test, right? Void test. This is just a test function, and in this I use a variable int x is equal to 0. Let's pause, and you define the prototype of this function in our header files, and control V, and remember these header files, they have this header definitions, uh, hash if not defined lcdh, then defined lcdh, and then endif. So you have to write your header file codes in between these two lines, before endif and within the if. This is done so that because the include file can be included in a number of files, so whenever the code is run, the definitions are not redefined. They are defined only once. Okay, so let's see, we save this, and in our main program, we include that file. These are the private includes. Hash include lcd. Remember, just by pressing the control and space, lcd8.h, right? This is resolved, means it has been found. And in our program, main program, if we call the main function, like here, we call the test function, so it is available, and we build the project, and it is giving some error. It could not find this lcdh file, so the path is not correct. Mhm. This is the include paths, not here. Include paths, and in this include path we have to add the new workspace lcd8. Okay, okay, apply and close. Yes, now let's build it. Now it has been built successfully, and there might be a warning because we have defined the variable x, but it has not been used. So there are 0 errors and one warning. So the test function, which is in our library, is now accessible from the main program, while this lcd8 is in a separate folder. So all you have to do is to add this folder to your include paths, search paths. That's it. But if you make the library by including the source file in this folder and include file in this folder, you don't have to do these source settings because these paths are already set there. So let's get rid of this function, and let's come back to our C program, and let's get rid of this function, and let's get rid of this definition. Right. Now, first thing that we need to do is that we have to define some global variables that will hold the pin values of the microcontrollers which are being connected to the character LCD. So how many pins we will be needing? How many variables will we will need. We will need 8 variables for data and 2 pins definitions for RS and uh, enable pins. So let's copy these files from here. LCDC, this is the file which I have already written, and also you will need a port definition. I will discuss it step by step. So let's come here and paste it here. So we have a variable named pointer to LCD port. So this will be the whole that on which GPIO port our pins are connected. Since all the pins will be connected on the same port, so we need it only once. Then we need a variable which is unsigned 16-bit number, um, LCD RS pin. I have just added LCD variable, the prefix, just to ensure that it is not does not conflict with any other variables, because remember these variables will be the global variables, and when you will include the library in your project, these global variables will be available in all the program. And then is the LCD enable pin. This is again unsigned 16-bit integer, and then is an array of 8 pins, LCD data pin 8. So these are the 8 pins which will be uh, used for data communication. So in the main file, we also include our hash include uh, lcd8.h file, so that all the definitions which we give there are also included in it. And in this um, header file, since we are going to address the whole libraries, we will be using this STM32 file. So in this folder, we include stm32f1xx.h file. This file is already included by system in your includes folder. Here you can see it's defined in the main h file, and it's included in your folder. Right. So first thing we have defined is that we have added these global variables, and we have included the microcontrollers include file as an header file into this file, and we have included this file into this file. So all these functions will be available in this process. Next, we have to make a function which we will call LCD setup. So in this function, we will be passing the port number, the register select pin, the enable pin, the and data 0 to data 7 pin settings that will be passing as a function, and we will assign these pins to our these global variables. So let's copy this function from here. Just for saving the time, I'm doing it. So you do it in the write this function in the LCD C program, because this is our library. So we have one function called LCD setup. Remember, LCD begins with small letters and S is capital. This is camel case protocol. So first parameter which we set is GPIO type def. GPIO type def is the predefined type for GPIO ports by the Hall library. Um, and if you want to see it, you can just press Control and enter, and this is the definition of this structure, because this is the port. In this port has CRL register, CRH register, IDR, ODR, etc. So all these registers have been mentioned in this file, in this structure. So GPIO type def pointer port, then unsigned int 16 RS, unsigned int 16 enable, and then unsigned int 16 D0, D1, D2, and up to D7. Then we have these global variables, which we have already declared here. We assign these past parameters back to these global variables. So after this function has been declared uh, in the library file, we have to define this function in our head file. So in our header file, we define this protocol, Control V, and this should end up with the semicolon. Now this function is available in our C file. Next function that we need is to write the data into the uh, LCD. And as we had seen, we need to toggle the enable pin after setting the data to write the data into the LCD. So we have this enable function. So just copy this enable function, and in our LCDC we write this function. So what does this enable function do? It does not take any parameters. It simply writes in HAL GPIO write pin LCD port. This is the global variable which we have already set. Enable pin LCD enable pin and GPIO pin set. So we turn that pin high, and after a delay of 1 millisecond we turn that same pin low. So giving a 0 to 1 and 1 to 0, this impulse will transfer the data from port pins into the LCD. So again, after writing this function, we have to define this function in our header file. So mention it here and here, and you should write void here else well, that this function will not take any parameters. Let's save them all. The next function which we will using is the LCD write function. So this is the main function which you need to discuss. Control C, and we write it here in our file. Right. So what will this function do? This function will accept a data of 1 byte, which will be unsigned int 8, means that this is an unsigned 8-bit data, one character, and it will write this data into the LCD port pins, and then the LCD port pins is using the enable pin to transfer it. So what we have done is, either we have to check the each bit of this data, whether it is 1 or 0, and then we have to set the corresponding the array pins as high or low. So what I have done is, for int I is equal to 0 to 7, and we check the data which has been passed with a mask 1 shift left I. So we test the data with a mask of containing only one bit and add it. If the result is yes, it means that that bit is also logic 1. So that bit we set in the array. And if it is not does not come to be true, then it means that bit of data is 0, and we set that pin to reset or 0 state. So after this loop is over, all the pins of the microcontroller have been set to either 1 or 0 according to this data. And this is in the array, so the pins can be arranged in an disorderly manner, but the pins will be assigned according to this sequence number. After this, we toggle the enable pin by calling the enable button, and the data will be transferred. So we write this function also in our header file control v. Now our library contains three functions. LCD setup, this will be called once to set up the pins, and then the LCD enable and the LCD write. So these three functions should be enough to start our LCD working, and after that we have to write a function which is called LCD command. This function will send a command to the LCD. As you know, there are two types of data which are sent to the LCD. One are commands and one are the text data which is to be printed. So commands are those which initialize the LCD and set the cursor position, etc. So for that, the RS pin has to be set low. So in the LCD command, again, we have to pass the command as a byte, and we first set the RS pin, which is defined as global variable to reset, means that RS pin is set to 0. This is the requirement of the LCD, that when you want to send the commands, you have to set the RS pin to 0. And then we write the command whatever has been passed to the LCD write function, and that will write and enable and toggle the bit. So this will write the command to the LCD. So again, we define this function in our header file, and we give a semicolon, and this function is defined. So next function which we need is the initialization function. So as we had discussed in our previous video, that various commands are to be given to the LCD in order to make it work properly. We will discuss these little bit here, but for that the details you have to see the previous video. LCD initialize. In LCD initialize, first we send the command 0x30. So 0x30 is 0011, and all the leading pins are 0. So this one will make the LCD come into the 8 bits mode. So if this number is 0, the LCD will be in 4 bits mode. So this one is the command flag, and this one indicates that it is, sorry, in the 8-bit mode. So this number 00110000 is hexadecimal 0x30. So we send LCD 0x30, and after that we have to give about 10 milliseconds time to take its effect. And the datasheet says that you have to repeat this function 3 times in order to make sure that the LCD is properly initialized. So we have sent 0x30, 0x30, 0x30 3 times. After that, we have sent the command 0x38. So 0x38 is 00, 1, 1, 1 and 000. So this one is again for the same thing, which is this 8-bit mode, and this one means that we want to set the LCD having 2 lines or more lines. If this is 0, that means single line, and if this is 1, this bit. If this bit, if this bit is 1, that indicates that the LCD will have 2 or more lines. So 0x38. So 0x38 is passed, and after that again we have given a 10 milliseconds delay. Then we have passed 0x0e. So 0x0e is higher 4 bits are 0 and lower 4 bits are 1 1 1 1 0. So these indicate the display is on, this and this one. This one's display is on, and C1 is equal to cursor is on, and this 0 means that blinking is off, and this is the control command. So when you give these commands LCD init, the display will be initialized and ready for accepting the data. So you just copy this function and put it into here as well. So now we will need first LCD setup, then we will need to send the LCD init. All these functions are internal for internal use by the library. So we will use just setup and LCD init, and this will initialize the library. Then we need to write one function more to write a character to the LCD. So one character is written at a time. So just copy this function and let's add it here. So LCD character, this will write one character which will accept an 8-bit data as CH, and simply because when you are just like a command, the RS pin has to be set to be 0, and when you want to send the data to the LCD which is to be displayed, the RS pin should be set to 1. So we have set the RS pin to set or logic 1, and then again use that LCD write function which we have already used and send it the character. So that's it, a simple part. Control C because video is getting longer, so I will just test it up to here and then we move on to the next video. So control V and semicolon. Right, so let's save all this and let's come to our main program. Now in our main program, we have already included this up our header file lcd8h, and in our main program, before the while function, user code begins here. So we call the function lcd setup, and if I press control and space, you see the function comes up itself. And now it is also pointing us what parameters it is expecting. It is expecting port. So our port is GPIO A, GPIO A. And now the RS pin is PA8. So we write here GPIO underscore pin control space, and here is the mask for pin 8. GPIO pin 8. And enable is same thing, pin number 9. So control C and control V and make it pin number 9. So D0 is the same thing, control V, except it is pin number 0. This is same thing, and this is pin number 1. This is pin number 2, and this will be pin number 3. This will be pin number 4. This will be pin number 5. This will be pin number 6. Although we are in using it pins in the same order, so pin number 7. But these can be in any order. Right? So LCD setup and semicolon. After that, you have to call LCD init, INIT, LCD init, and LCD will be initialized. And we can write just one character, LCD control space and char, this function, and let's pass it 65, which is the NC code for letter A. So up to now, the LCD should be initialized and should display a character 65. So since we are going to use this library in our simulator that needs hex files, so we have to set up the project properties and post build options and convert to hex files. Right, now let's generate the code. Not build all. Project, build project. And now we call our library simulator. And in simulator, first thing which we have to set is the file, the program file, and we are using library 2 and in debug, and this is the LCD hex file. Right, so let's magnify our display a little bit and run the code, and you can see there is a letter A, LCD is on, and cursor is also on. So so the first part of our library is complete, that we are able to initialize the library LCD and we are able to write a letter A. And in our next talk, we will extend this library to display the strings, numbers, and other control things. I hope you would have enjoyed it. Um, Thank you very much. Stay blessed.